What's up everyone, Steven here with TechMaker.tv. This is building a decentralized chat with Node JS and aleph.im part 10. So far, we haven't done much in the way of data modeling. Essentially what we've done is just use this sort of default, well not default, but the format that's sort of prescribed in the simple dApp example application that Aleph has over on their GitHub. And as you can see, the data for this is really simple. Essentially, we just have a content with a body, which is the message, and there's a type of chat, and there's a reference to hall, which is just the chat room. So this is perfect for having just a simple chat room like the demo app. But what if we want to build out something a little more sophisticated where a user can create their own channels or join other people's channels, potentially request to be added to a channel or invite people, something more like a Slack or a Discord? Well, we're going to need more sort of objects and the way to look those up. So if you go back through, we made a couple of kind of, you might say, boring episodes for the past couple of days on how to query with Aleph. And honestly, it was just sort of exploring. There's probably a lot more that I don't know, but still, if you are totally lost as we go through this, be sure to check back over there. But in any case, what I want to do in this episode is just map out what the data model is going to be. It's going to be pretty simple, but I want to kind of explain the details. And then in the next episode, we're going to start building that out. And it'll probably take us, 2 or 3 or 4 episodes at least to kind of get all the way through. So I found this website called Sketch.io, which I've never even used before. So we're going to try this out. And it may look hideous because I've never done this. And I'm going to try to draw on my trackpad. But it's probably the easiest way to actually get something going. I wonder if there's shapes. It doesn't matter. Let's not get into all of that. So let's imagine for a second we were going to build this in a conventional database. So I have kind of a semi-UML, like sort of loose sketching thing that I always do. Shapes doesn't really matter. That's not really a circle, but we could have like a... Okay, that's way bigger than I want it to be. Let's see if I can do this. Normally we might have like a user model. Yeah, this kind of works. If I could just, nope, not that. How can I move this dude? All right, we're going to get this. Okay, fair enough. Okay, so normally we would have a user, like every system has some kind of user. And again, like this isn't a conventional database, so you might have email, password, some kind of OAuth login, username, name, user details, profile, so on and so forth. Let's just all assume that's in this user concept. And then maybe you would have, let's see, so you might have like over here, in the case of like a Slack, you might have a channel. Let me not try to write with this pencil. That's going to be annoying. So you might have like a channel. Let me see if I can just quickly, boom, there we go. Getting better already. So obviously I'm oversimplifying the data model of something like Slack, but it would be something kind of like this. And again, we're doing this as if we're inside of a conventional database, and we're going to map it out, and then we're going to switch gears and talk about how to do it with Aleph. So normally what you would do is if you want to say like a user can belong to many channels and a channel can have many users, that's what you call a many-to-many relationship. A one-to-many relationship would look something like, let's just do like blog, and then you have like a comment. And so the way that we would typically signify that something belongs to something else is we would draw an arrow from one thing and point it at the other. And what this would indicate is that this comment belongs to this blog post. And so if you think about that, what that literally means is in our database, we're going to have a blog, which is going to have an ID. And then you have a comment over here, a whole bunch of comments that have different IDs. They all have their own ID. But all of those comments, if they belong to that blog post, would have a blog ID, a blog post ID or something like that. So that, like, let's say this blog was ID number 10 in the database, and then you have comments 40, 97, so on and so forth, but each one of those have a blog post ID of 10. if I remember that number correctly. And that way, essentially what we can do is map this thing over here and say, whenever we load that page, hey, look up the comments that all belong to this specific post. Okay, so I felt like I wanted to go ahead and discuss one-to-many in case somebody hadn't seen that before. So many-to-many is more complicated. And what we have to do typically is create what's called a join table, or if you're like in something like Rails, you might call it a join model. And what that is an object that sits in the middle. In this case, it looks sort of like an egg without smooth sides. And we might call this something like channel membership, something like that, and put like that. And then what we're going to do is draw our arrows like this, and we'll say that this channel membership belongs to the user and it also belongs to the channel. And so whenever you have this arrow, like with our blog and comment thing, I shouldn't have erased that so quickly. The comment has what's called a foreign key. So that blog post ID is what's called a foreign key and points over toward the blog itself. So in this case, in the arrow, always in the way that I draw it, it always starts wherever there's a foreign key. So what this would look like is, let's say that we had a table, and I don't know how this is going to work, but let's try this out. Let's say that we had our channel memberships table, something like that. And then in the table, this is kind of crazy how this works. Let's say we had several attributes. You have the ID. Well, normally actually what you would have is like an ID, a user ID, and a channel ID. And what this means is, like, if I want to say, like, let's say that I have a user object, and I'm using certain terminology based on my programming background, which is mostly like Ruby. But let's say we have this user object in hand and we want to find out like which channels belong to that user. What I can do essentially is pull back all these channel memberships for this user by looking it up based on give me all the channel memberships with this user ID. And then I can look at those channel memberships and then I can say, okay, give me all of the channel IDs off of those intermediate objects. And we can say, okay, this is all the channels that ultimately belong to this user. And we could do the same thing in reverse. So that's kind of a brief overview. The thing is, you would do this really differently in like an SQL database than we're going to do with Aleph. I'm not 100% sure exactly how all the queries are going to work out, but we can't do, as far as I understand, any sort of like fancy joins or anything like that, which we're going to have to sort of take into account when we're designing the interface and how we want things to load and so on, if we don't want it to be a really, really wonky experience. So let's get rid of that. And then the other aspect of the model is the message. And I'm just going to stick that down here under channel because that's obviously where that's going to go. And let's go ahead and put this here. So a message typically is going to point up at the channel. So it has the channel ID on it, which makes sense. That means that, you know, we load the channel and then we can load all the messages that belong to that channel. And it's also going to have a user ID typically. So that's like when you're looking at Slack and you can actually see the name of the person who wrote the message, it's because that message is able to pull back and say, okay, I have a user ID, so I belong to this user, and then I can provide all the various user details from that bit of data. So this is our sort of super simple domain model. But one of the things that's kind of different is in our system. So this is sort of like if I was building a Rails app, this would be like 4 commands to create all these models and set up all my relationships and everything. No big deal. With Aleph, so we've already got a user. Let me actually see. Do I have the code still pulled up here? Yeah, it looks like it. So let's look at my index.js. So inside of here, we've got this register, and so we have a user object. So we already have a user here that's got this username and password, and then we update their private key, public key, and all this stuff. And we've talked about this before where we need to change this up potentially in the future. So in any case, we won't worry about that now, but just keep in mind we have a user record in our database, and I think it's Mongo that we're using here in our actual app. So let's go back over to the browser and let's look at the Aleph Explorer again. And you can see that all the messages that get posted have an address. And you can also see that back over in our code, we're saving the public key here. So actually the address down here, sorry. So those things are going to match. And so whenever we post to Aleph, the transaction is signed with this address, so we know it came from us. So that's kind of something a bit different than a typical database. So essentially what we're doing is we're saying, okay, this over here is all sort of in a different universe, kind of, than the rest of this stuff, because these three things are going to live on Aleph. So one nice thing, so we talked about this foreign key thing. Any message of any type that we post to the Aleph network is going to have our address on it. So we can look at channel memberships, channels, messages, anything that gets created, and we can see who owns it by default. Now, we won't use this channel relationship directly other than maybe to see like who the channel owner is potentially. Because it depends on the business logic of the app, but if we decide that we want it to be where, I create the channel and therefore I'm the owner, then we could do that because the address is there and we can see who executed that create command essentially. But we will be using that address on the channel membership and on the message. So the way that I've sort of worked this out for how I'm going to do this app, and this is again is a simple example, but the way that we're going to do this is, first of all, let's look at a couple of things. So we have this type here. So I'm sort of imagining that this is the table name. So I'm going to have a type called channel memberships. I'm going to have a type called channels. And I'm going to have a type called messages. And I'm naming them that way because that's how I would name database tables. We may decide that's not a good idea in the future, but for now, that's what I'm going to do. So that's going to go in the type, and that's going to help us look things up because we can base, if you go back to the query videos, we can base the queries based on, sorry, it's a lot of the word based. Anyway, we can base the query on the name of this table to start, so that will help us filter things out. So the question then is, how do we set up these relationships between these models? And as we looked at, we don't really need to do that for like the address stuff that points at the user because everything's automatically going to have this address, and we can look things up based on address as we looked at in the query video. So the question then is like, how do you connect to the channel? So let's say we have a channel membership object that we're trying to pull back the channel from. So we know we have the address. How do we attach something related to the channel? So we have to assume, okay, in this case, that a channel already exists. And when something exists in Aleph, if we go over here to this raw stored, you can see that we have this item hash, and we can look things up based on this hash here. So actually that is, I just tried this in my terminal a little bit ago. So that's the item hash right there. If I cycle up one, you can see that we have the F0B28 there, F0B28. So that's the same thing. If I hit enter, it's going to pull back all of this data, and you can see here that we have the same content, body, high, so on and so forth. So that is the same thing, and what that means is, what I think we're going to do is, again, pretend that this is this channel membership. So the channel membership has the address, so we know it's that. It has channel membership here, so we know it's a channel membership object. What I'm going to do is put that hash for the channel that it belongs to into this ref argument or attribute. And what that's going to let us do is look up. So once we pull back all the channel memberships that belong to this user by their address, we can look up the channel. So the last thing that's really left is this message. So, and again, this already has the address of the user automatically on it. So what I'm going to do again is put the channel hash in the ref on the message, so that whenever I load my channel, I can say, okay, give me all the messages that have my own item hash in the ref. At least that's how I'm thinking about it now. I think this will all work. I've tested it enough ways now that I think that's about right. The one question I do still have, which I need to work out, is let's say we want to show like the username of the person on the message. So right now in the app, we're just printing out the address, which is easy because it's just automatically on the message. But what if we want to put their username? So what I mean by that is, if you're looking at a chat thread, you're going to have like a message, and then normally below it or above it, you'll have like, this is who said it, something like that. So if we want that, theoretically in a normal database, we would just call back over here to this user thing, but we can't because the user is actually stored within our server that's running on our computer in this case. And because this segment, all this stuff to the right of this kind of curvy line, because that is all decentralized, theoretically other people could be creating user interfaces on top of our system essentially, or our network. So they may not all have, they definitely won't have all of the same data in their database. So there's no way to call back over here to this user. So Aleph does have a way to, I think, identify an account with a username or something like that in it. I don't know exactly how that works yet. I'm going to look into that. And I also don't know how efficient that will be. So what may happen is we might do what you call denormalization, where we actually put a little bit of extra data in the message related to who said it. So like, let's say that our app has a username or something like that. We might require that when you define the data that goes inside each of these objects, if you're the application designer, in this case, which we are, and even if you want people to use it in a decentralized manner, you can put the specs out there and say, hey, if you want to use this system, here's what you need to include in order for this to make sense. And I guess theoretically you could say, you got to put a username. What I don't know, and this gets into some other sort of outstanding issues that I'm starting to think through the more I dig into this, because all of this stuff is really cool in theory and it's cool in practice, but I don't know how to do data validations. There's not really a way, as far as I can tell, to put data validations like on the network and say, don't save this record unless X, Y, and Z are present. I don't really think you can do that. So I'm not 100% sure how you would prevent, data that comes from sources that are untrustworthy from showing up in your app, for example. So that's one of the things I'm thinking about. Kind of done explaining the data model. I just wanted to riff on a couple of thoughts before I end into this. The other thought that I have is this all makes sense because we have this address that's ultimately one of the foreign keys as the address. But what if you had like two things that were not, let me show you what I mean. What if you had to do a many-to-many that didn't involve like an actual user account? So let's say you have, let me draw 3 circles here, or some things that approximate circles, sort of, depending on your fault tolerance. So let's say we had a class, and then I'm done with that. So you have a class. Over here you have a student. This is kind of a classic example. So you have a student over here, and in the middle you have something you might call like an enrollment. So this is a classic many-to-many example. That's fine. We all know what that says. So an enrollment obviously is my membership in a class, and then the class can tell which students are in it through this sort of middle object. So the reason this is, in my mind, kind of problematic right now is, this all works because we are always using the user address as one of the foreign keys, but down here, that wouldn't necessarily be the case, or it wouldn't be the case. So you really need some kind of student reference and then the class reference. Maybe I should have called that course so that it's not confusing with like the programming terminology. But anyway, so now you would have so you have a course reference, you have a student reference. So I think that you can pass in an array here. I think if that's the case, maybe it would make sense to say like pull back, I guess if you're storing, okay, I'm just kind of thinking through this. So if you store these, if you can store an array and you can search by things in the array, which I'm guessing. If you were to search by, if you stored like the item hash of the first object and the item hash of the second object, I imagine this is totally unique. Like you're never going to get duplicates of this ID in any type of object. If that's the case, then you could feel free to stick any references you want in here, and then that would solve the problem of the foreign keys. So I'm just thinking out loud. We don't actually have this problem yet. It might be worthwhile to sort of explore that. Instead of just using the address by default as a foreign key, maybe let's try to use like, like stick the actual, I don't know what other object we have in there. Maybe the address would be fine, put it in the references. I don't know. Things to think about. All right, I'm kind of done riffing there. I think this top bit explains, and the explanation kind of walks through, what we're going to build. The next episode, we're going to code out building a channel and a channel membership. Then episode after that, we're going to code out, posting messages to our channel and so on. So that's it for this one. If you like this video, be sure to hit the subscribe button, hit the like button, hit the bell button, hit all those things. And thank you so much for watching, and I'll talk to you in the next episode.